Title: Distortion of Spacetime Around Light and Fast-Moving Electrons. Hello, everyone. Today, I would like to discuss the phenomenon of spacetime distortion around light and fast-moving electrons, as explained by Einstein's general theory of relativity. The spacetime around light and rapidly moving electrons is also distorted. Gravity is the curvature of spacetime caused by mass and energy. Therefore, the presence of mass or energy leads to spacetime distortion. Light and fast-moving electrons, possessing both mass and energy, contribute to the distortion of spacetime. Although the mass of light is extremely small, its energy is significant. Consequently, spacetime around light is distorted, albeit in a very subtle manner, measurable through precise experiments. The mass of fast-moving electrons, like light, is much larger than that of light. Thus, the distortion of spacetime around fast-moving electrons is considerably greater than that around light. Indeed, experiments have been conducted to measure the distortion of spacetime around fast-moving electrons. Observations from these experiments confirmed the distortion of spacetime around fast-moving electrons, providing evidence supporting Einstein's general theory of relativity. In conclusion, spacetime is distorted around light and fast-moving electrons. Gravity and mass are closely related, as objects with mass distort spacetime, influencing other objects with gravity. This phenomenon can be explained by Einstein's general theory of relativity, which considers spacetime as a four-dimensional curved surface. Objects with mass warp this surface, affecting the path of light moving through spacetime. The confirmation of this theory came in 1919 when British astronomer Arthur Eddington observed the bending of light due to the gravity of the Sun, providing experimental verification for the general theory of relativity. The distortion of spacetime around light and fast-moving electrons can be observed in various phenomena, such as the bending of laser beams by the Sun's gravity, the generation of gravitational waves in collisions between electrons and positrons, and the distortion of light around black holes. These phenomena are considered crucial evidence for the general theory of relativity. Title: Distortion of Spacetime Around Light and Fast-Moving Electrons. Hello, everyone. Today, I'd like to discuss how spacetime is distorted around light and fast-moving electrons, as explained by Einstein's general theory of relativity. According to the theory, mass and energy distort spacetime, causing any object with mass and energy to create a distortion in the surrounding spacetime. While light has no mass, it possesses energy. Consequently, light causes a distortion in the surrounding spacetime. Although this distortion is extremely subtle, it can be observed with precise measurement equipment. Electrons have both mass and energy, resulting in a distortion of spacetime in their vicinity. This distortion is larger than that caused by light but is still very subtle. Nevertheless, it can be observed with sufficiently precise measurement equipment. In fact, a successful experiment measuring the distortion of light was conducted at the CERN laboratory in Geneva, Switzerland, in 1979. In this experiment, the path of light was observed to be distorted when it passed through a mass-containing object. Furthermore, in 2016, a successful experiment measuring the distortion of electrons was conducted at Fermilab Laboratory in the United States. In this experiment, the path of electrons was observed to be distorted when they passed through a mass-containing object. These experimental results serve as evidence supporting the correctness of the general theory of relativity. Title: Enhanced spacetime distortion around electrons moving at the speed of light. The phenomenon of spacetime distortion is more pronounced around electrons moving at the speed of light than around slowly moving electrons, primarily explained by Einstein's general theory of relativity, which posits that mass and energy distort spacetime. According to the general theory of relativity, objects with mass distort spacetime, and the greater the mass, the more severe the distortion. Since energy is equivalent to mass, higher energy levels also lead to more significant spacetime distortion. Electrons possess both mass and energy, resulting in spacetime distortion in their vicinity. While the distortion around slowly moving electrons is minuscule, it becomes exceptionally pronounced around electrons moving at the speed of light. This heightened distortion is attributed to the substantial mass and energy associated with electrons moving at the speed of light. The speed of light, approximately 300,000 kilometers per second, is incredibly fast. The mass of an electron moving at the speed of light is about 200,000 times the mass calculated in classical mechanics. Consequently, the spacetime distortion around electrons moving at the speed of light is roughly 200,000 times more severe than that around slowly moving electrons. Spacetime around slowly moving electrons affected by resistance is nearly flat. However, Around electrons moving at the speed of light, spacetime is highly curved, indicating a significantly more intense distortion. These spacetime distortion phenomena are observable in various cosmic events, such as the bending of light due to the gravity of the Sun and the distortion of spacetime around black holes. Title: Increased magnetic field strength due to electron rotation at the speed of light in a flat disk. If an electron rotates at the speed of light within a flat disk, the magnetic field becomes more powerful in the orthogonal direction. This phenomenon can be explained by the electromagnetic induction effect. Electromagnetic induction is the phenomenon where an electric field is generated when a magnetic field changes. When an electron rotates at the speed of light, a magnetic field is produced due to the electron's charge. This magnetic field forms a circular pattern centered around the disk's axis. The electrons located on the outer edge of the disk experience a stronger magnetic field. Consequently, electrons on the outer edge undergo a greater force due to the magnetic field. This force influences the electron's motion, leading to a change in its velocity. As the electron's velocity changes, so does its charge. A change in charge results in a variation in the magnetic field strength. Therefore, the magnetic field strength is enhanced on the outer edge of the disk. This phenomenon can be mathematically expressed using the formula B equals frac mu_0 CDOTI R. Here, B represents the magnetic field strength. mu_0 is the magnetic constant. I denotes the current. R is the radius of the disk. Hence, if the current remains constant, the magnetic field strength is inversely proportional to the disk's radius. In other words, the magnetic field strength is stronger on the outer edge of the disk. Observations of this phenomenon can be found in various cosmic events such as remnants of supernova explosions, the surroundings of black holes, and neutron star environments. These occurrences play a crucial role in advancing our understanding of the universe.